This video is going to cover the topic of theoretical probability. Be sure the date and topic are at the top of your page. The essential question for this video is, what is theoretical probability and how do we represent it? Be sure that you have the essential question written down on every video for our class. The essential question needs to be recorded on every video you watch, so be sure at this time that you have recorded it. Be sure also that you give yourself time to watch and pause the video to take notes, as that's what we'll be looking at in class. We are going to talk about probability, a term that you've probably used and heard a lot. In math, when I'm talking about probability, I'm thinking about the likelihood or chance that something will happen or occur. For example, we're going to talk first about flipping a coin. If I'm talking about the probability of flipping a coin, then I'm probably trying to calculate, for example, how likely it is that the coin will land on heads. Right? A term we'll also hear a lot is theoretical probability, and that's how likely something is supposed to happen. Here I've really bolded this word should, because it doesn't mean in real life that it will actually occur this way. But in math, we can figure out what the chances are of something happening in a theoretical way, right? In this kind of perfect mathematical world. Let's think about our coin. Since there are two sides to a coin, you would probably correctly think that if you flip it, you should have an equal chance of getting either heads or tails. This idea of what should happen is this theoretical probability. That's what should happen. Now, if someone really flipped a coin over and over again in real life, they might get heads every single time. When that happens, that's us doing an experiment. We call it experimental probability. We'll have some opportunities to actually do some experiments, having us test different outcomes for different items, and that will be our experimental probability. But let's talk more about theoretical. Finding the theoretical probability of something is basically finding a ratio. And one way to write a ratio is in the form kind of as a fraction. Hopefully we remember that from our previous work with this. So we can write our theoretical probability, as a ratio. One way to think about this ratio is as the number of outcomes that match what we want, right? Our desired outcome, what we're looking for, out of all of the possible outcomes there are, all the different things that could happen when we're thinking about our options. Let's go back to the coin to make this a little more clear. In our coin, let's say I'm hoping to get heads, right? My desired outcome, what I'm wanting, is heads. I'm going to write that as this, the probability of getting heads. So inside the parentheses, I'm going to record what it is I'm looking for, and I'm looking for heads. In a standard coin, there's just one side, right here, that is head, right? So the number of possibilities that I have to get what I want is 1. There's just one possible outcome that's what I want. Now, there are two options. When I flip the coin, I could get head or I could get tails. So that's two different possibilities. So that's going to be my denominator of this ratio set up as a fraction. So I can write P heads, probability of getting heads, is 1/2. And then often we'll think of that as, oh, that's the same as 1/2 this way, which is the same then as 50%. So the chance of getting heads is, of course, 50%, which I'm sure you already knew. Now let's think about a number cube, or a die, right? This is my best approximation here of my number cube. Of course, it has 6 sides. But let's say I want to know the probability of rolling a 3. So theoretically, if I roll the number cube, I'm trying to think about how likely it is that I will roll a 3. Now, there's only, if I list out what I have here on my number cube, there's only one way to get a 3. Right? So that means there's one way to get a 3, and there's a total of 1, 2, 3, 4, 5, 6 different sides that it could land on, right, on our standard number cube. So that means that it's 1 out of 6 that I will get a 3. And unfortunately, it doesn't mean that every time I do 6 rolls, one of them will be a 3, but it gives me a sense of how often it would be in a perfect mathematical world. Here's one that's a little more interesting, right? That makes us think a little bit further. What if I want to know the probability, theoretical probability, of rolling a factor of 6, right? So here again, I have my numbers listed out. So on a standard number cube, these are the sides of my die. And if I'm looking for the factors of 6, those are numbers, kind of building blocks that can be multiplied to make 6. I know 1, 2, 3, and 6 itself could all make a 6, right? Those are all factors of 6. So that means there are 4 opportunities out of the total of 6 that would be what I want, right? 4 out of 6 chances of getting a factor of 6. For one last example, of my number cube, let's say I want to figure out, for whatever reason, I need to know how likely it is that I'll either get a 1 or a 4, right? Both of those things will work for what I'm trying. Well, in that case, right, here's my list. In that case, I have a 1 or a 4. Together, those make up 2 ways that I could win, right, if this is some sort of game I'm playing. But I have 2 ways to meet the conditions that I'm looking for out of the original 6 possible choices. And of course, in both of these last 2 examples, I actually could rewrite my ratio, right, in a more simplified form. So this would be 1/3, right? That would work, and this would be 2/3, right? Those are also steps I might take as I am describing my probability. So we're going to be working with probability a lot. We're going to do a lot of activities with probability, but this is just a good introduction for the term theoretical probability and how we write it. Be sure to bring your notes to class, and if you have any questions, write them in the margins, and feel free to rewatch this for any parts that you might need clarification.